Two sources of light are said to be coherent if the waves produced by them at any point in a given medium have same. Options are given. Coherent sources have same frequency, constant phase difference. Therefore, in a given medium, they have same wavelength also. So among the following answers, option C is the correct one. That is, they have same wavelength and constant phase difference. In Young's double slit interference experiment, the distance between the slits is 0.05 centimeter and screen is 2 meter away from the slit. The wavelength of light is 6 into 10 raised to minus 5 centimeter. The distance between consecutive maxima is, that is, distance between consecutive maxima we can write as fringe width beta equal to lambda d by d, where lambda is the wavelength, that is 6 into 10 raised to minus 5 centimeter. D is the distance from the slits to the screen. That is, if these two are the slits, and here if you are getting the interference pattern, distance from the slits to the screen is D. So it is given 2 meter away, that is 200 centimeter away, divided by D is the distance between the slits, that is given as 0.05. When you calculate this, you will get 0.24 centimeter. So option A is the correct one. In Young's double slit interference experiment, if the slits made threefold, the fringe width becomes. Equation for fringe width is lambda d by d. That is lambda d divided by small d becomes threefold. So it is 3d, or we can write 1 by 3 into lambda d by d. That means this is beta. So 1 by third of beta. So the new fringe width becomes 1 by third of fringe width. That is option A is the correct one. In Young's double slit experiment using blue and red light, the wavelength of red light is 7.8 into 10 raised to minus 5 centimeter. That of blue is 5.2 into 10 raised to minus 5. The value of n for which n plus 1, the blue bright band coincides with the nth red bright band. For bright bands, we can write n1 lambda 1 equal to n2 lambda 2. For the red one, it is n. So n1 is n. And lambda 1 for red is 7.8 into 10 raised to minus 5. And 2 for blue is n plus 1. And for blue, lambda 2 is 5.2 into 10 raised to minus 5. You can calculate n divided by n plus 1 equal to 5.2 divided by 7.8. That is 2 by 3. That means you can cross multiply and you will get 3n equal to n plus 1 into 2. That is 3n minus 2n equal to 2, or n equal to 2. So option C is the correct. In Young's double slit experiment, if the monochromatic source is replaced by source of white light, options are given. Among these, option D is the correct one. That is, central fringe will be white and others are colored. Two coherent waves having intensities in the ratio 9:1, that is I1 by I2 is 9:1, produce interference. The ratio of maximum to minimum intensity in the interference pattern is equal to, that is I max by I minimum is equal to square root of I1 plus square root of I2 whole square divided by square root I1 minus square root I2 whole square, or you can rearrange the equation as square root of I1 by I2 plus 1 whole square divided by square root of I1 by I2 minus 1 whole square. That is square root of 9 by 1 minus 1 whole, sorry, plus 1 whole square divided by square root of 9 by 1 minus 1 whole square, or 3 plus 1 whole square divided by 3 minus 1 whole square. That is 4 square divided by 2 square, or 16 by 4. That is 4 is to 1. So option C is the correct one. In two separate setups of young double slit experiment, fringes of equal width are observed when lights of wavelength in the ratio 1:2 are used. If the ratio of slit separation in two cases is 2:1, the ratio of distance between the planes of the slits and the screen in the two setups is. Options are given. We know that beta equal to lambda, fringe width beta equal to lambda d by d. Here, fringes are said to be or of equal width, that is beta 1 by beta 2 equal to 1:1, and wavelength in the ratio 1:2. Then slit separation d1 by d2 in the ratio 2:1. Let us find out d1 by d2. So from this equation, beta 1 by beta 2 is equal to, for two experiments, lambda 1 by lambda 2 into, because lambda is directly proportional, d1 by d2 into d2 by d1, because small d is inversely proportional. So from this we will get d1 by d2 is equal to beta 1 by beta 2 into lambda 2 divided by lambda 1 into d1 by d2. Let us substitute the values. That is b1 by b2 1, then lambda 2 by lambda 1 2 by 1, d1 by d2 again 2 by 1. So answer is 4 by 1 or 4:1. Option A is the correct one. If yellow light emitted by sodium lamp in Young's double slit experiment is replaced by monochromatic blue light of same intensity, options are given. We know that fringe width beta equal to lambda d by d, or beta is proportional to lambda. If you consider yellow and blue light, in Vizier we know that, see, from violet to red, lambda increases. So, lambda of blue will be less than lambda of yellow. So, when we replace yellow light by blue light, lambda actually decreases. That means beta also decreases. So, option A is the correct one. Polarization of light proves. Options: corpuscular nature, quantum nature, transverse nature, longitudinal nature. Among these, option C is the correct one, transverse nature, because only transverse waves can be polarized. So it proves transverse nature of light. If the ratio of intensity of scattering of two light is 1:81, the ratio of their wavelength in the same order is, ratio of intensity is given. I1 by I2 is equal to 1:81. For scattering, intensity is proportional to 1 by lambda raised to 4, or I1 by I2 we can write lambda 2 by lambda 1 whole raised to 4. Or we can write lambda 1 by lambda 2 is equal to I2 by I1 whole raised to 1 by 4. That is 81 divided by 1 raised to 1 by 4. That is 3 by 1. Option D is the correct one.